Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video presents the basic concepts of the central limit theorem. Let's get started. The central limit theorem provides a very important tool for our statistics toolbox. The reason being is that the central limit theorem says that for a population with any distribution, the distribution of the sample means will approach a normal distribution as the sample size increases. What this means is that the tools that we've learned so far for dealing with normal distributions, we can use with any distribution if we can apply the central limit theorem. Now, this actually forms the foundation for estimating population parameters and hypothesis testing, which we'll get into in future mini lectures. So, central limit theorem is an important tool in our statistics toolbox. There are some assumptions that are made with the central limit theorem. First, we're assuming that the random variable x has a distribution with a mean value that's equal to mu and a standard deviation value that's equal to sigma. Then we're also assuming that simple random samples of all size n are selected from the population. Remember that a simple random sample is one in which all possible samples of the same size have the same chance of being selected. So, assuming that we have a distribution, and it can be any distribution, it could be uniform, it could be exponential, it could be, whatever it is, it could be any distribution. Okay, we're assuming that there is a distribution that has a mean value and a standard deviation, and we're taking simple random samples from that distribution. If these assumptions hold true, then the central limit theorem is going to make the following conclusions. First, the distribution of the sample means will, as the sample size increases, approach a normal distribution. And of course, with the normal distribution, we can use the tools that we've learned so far in previous mini lectures for dealing with normal distributions. We're assuming that we conclude that the mean of the sample means is going to be the same as the population mean. So we can actually know what the population mean is without knowing the value of every member of the population. We can also know what the standard deviation is. Of all the sample means is going to be that standard deviation that we saw earlier from the earlier distribution that we know what that is. We're going to divide it by the square root of our sample size. So we make this adjustment and that gives us our standard deviation. There's some conventions about the central limit theorem that we need to keep in mind. So here's some commonly used notations that you see in relation to the central limit theorem. First, the mean of a sample means, usually written mu sub x bar. This is the population mean. So this is going to be the same as, the population mean mu. Standard deviation of the sample means, usually written sigma sub x bar. Keep in mind that this value is also known as the standard error of the mean. Now, some commonly used rules when applying the central limit theorem. First of all, if we have a sample size that's larger than 30, then we can approximate the distribution, whatever that distribution is, of the sample means reasonably well with a normal distribution. So no matter what distribution we're getting our sample data from, if we have a sample size that's larger than 30, central limit theorem says we can use a normal distribution as a reasonable approximation. As we increase the sample size, we're going to get closer and closer to that normal distribution. That's what you see over here on the right, where with a sample size of 1, let's say you get a distribution that looks like this. When the sample size is 4, you get a distribution that looks more like this. And notice how we increase the sample size, and that distribution gets more and more closer to what we would identify as a normal distribution. So no matter what distribution we start out with, central limit theorem says if we have more than 30 in our sample size, then we can use the normal distribution as a reasonable approximation for the sample means. Now, if we're already normally distributed, then, there's no need to make a jump to anything. There's no need to approximate anything. If we're already normally distributed, then there's no threshold we need to reach. We're already normally distributed. So just go ahead and use the tools we learned in previous mini lectures for normal distribution. Let's look at an example. We've actually seen this example before, the central limit at work, when we conducted our rolling dice experiment. So remember, we got a uniform distribution when we were looking at the probability of rolling any one number. But then, as we simulated more and more rolls, remember the distribution of those sample means became a normal distribution. This is the central limit theorem at work. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.